Hi, this video is on FRQ problem number 2 from 2016, and this is a calculator problem. So the problem says, at time t, the position of a particle moving in the xy plane is given by the parametric function x of t, y of t, where dx dt equals t squared plus sine of 3t squared. The graph of y consists of 3 line segments is shown in the figure above. At t equals 0, the particle is at position 5, 1. So the first thing you should notice is that this is a parametric function problem, and it is a BC topic, and they've provided you with dx dt, and though they did not give you dy dt, you do have this graph. Part A asks you to find the position of the particle at time t equals 3. For this problem, it is important that you notice that they gave you an equation for dx dt, which was dx dt equals t squared plus sine of 3t squared. Next, it's very important that you took notice of the axis labels for the graph. Without noticing that, you would not have been able to do this problem completely because you would have never found the y of t for this problem, so read the axes carefully. This problem was awarded 3 points. 1 point was for using the initial condition that at x equals 0, the value is 5. This was given in the problem. Second point was awarded for setting up the integral using the dx dt function they provided. The area under dx dt is the x value from 0 to 3 that you add to the initial condition of 5. To solve this integral, you could simply plug it into the calculator. On the TI-84, you click on the Math button and then 9, which corresponds to 9 on this menu, which is integrating. And you can plug in the limits in the equation, and the calculator will give you the answer for that, and that is the x coordinate. And the third point was awarded for getting the actual coordinate, the x and y. Even if you didn't read the axes and you only found the x-coordinate, you would still receive at least 2 out of 3 points, but for the third point, you must have the y-coordinate. And you would get that because the problem is asking for at time t equals 3. So if you go here at time t equals 3, y of t is negative 1/2. It's just simply reading the graph. Part B asks you to find the slope of the line tangent to the path of the particle at time t equals 3. For this problem, it's important that you differentiate between what a velocity vector is and what the slope of the tangent line is. The velocity vector is written in the form x prime of t, y prime of t, and it gives the velocity of the x values and the y values in respect to time. The slope of the tangent line is the slope the line would be if you were to draw the line on the graph. It does not mean velocity. This is a very important differentiation to make. The slope is dy dx, so to do that, you do dy dt over dx dt, which gives you the answer of 0.05. You find y prime of 3 by finding the slope of the line on the graph of y of 2 at 3, which is 0.5. You can find x prime of 3 using your calculator. On the TI-84, you hit the Math button and then number 8, which corresponds to number 8 on the menu here, which is deriving. And divide those two values to get the answer. This question was only worth 1 point. Part C asks you to find the speed of the particle at t equals 3. For this problem, you must know the formula for the speed of parametric functions. It's the square root of x prime of t squared plus y prime of t squared. The problem asks for the speed at time t equals 3, so you plug that in and get your answer as 9.969. You already found x prime of 3 and y prime of 3 in the previous part, so you don't need to do that again. There's no way for you to get any credit on this problem without knowing the speed formula, so you must memorize that formula. This question was worth 2 points. 1 point was for writing out the expression and showing the formula, and 1 point for the correct answer. Be careful that you do not set the general equation equal to the expression at time t equals 3 because that's not true. This is the speed at time t equals 3. This is the speed at any time. And note that there's no equal sign between those. And also, don't jump straight from the general formula to this because it's the same idea. This is not necessarily equal to that. And you must have written this to get credit for the problem, showing that you know what the speed formula is and that you can plug in 3 into it. Part D asks you to find the total distance traveled by the particle from time t equals 0 to time t equals 2. For this problem, it's important to have the distance formula memorized. It is the same as the formula for speed, except you integrate that. And this makes sense because usually you would take the integral of the absolute value of the velocity function, which is the speed, to find the total distance. So you are applying the same concept here. The integral from 0 to 2 has been split into two integrals from 0 to 1 and 1 to 2, because if you look at the graph of y of t, it's not differentiable at t equals 1. Looking at the graph of y prime of t from 0 to 1, the derivative is negative 2. From 1 to 2, y prime of t is 0, so you would plug that in. Now, using your calculator, you can plug in x prime of t, which was given in the function, to find the integral. On the TI-84, you press the math button and hit 9 to do the integral. In this problem, you get 1 point for writing down the formula itself. As you've probably noticed by now, the College Board tends to award points for writing down the formula, as they did also for part C of this problem. Even if you didn't realize that you had to split the integral because at t equals 1, it's not differentiable, or you got stuck because you didn't know what to do, you should still at least write the formula so you can get at least 1 point for this part of the problem. And the next point was awarded for splitting the integral, and the last point was for getting the correct answer. So these are just some recommended practice problems. Problems 21 and 22 from section 10.2 focus on finding a coordinate on the parametric graph, which is a skill set that was needed for part A of this problem. Questions 1 through 10 from the same section focus on finding slopes of tangent lines, which is a skill set that was needed to do part B of this problem. Questions 51 and 52 focus on finding the distance traveled, which is what you needed to know how to do part D of this problem. And lastly, this link here is just a link with a bunch of practice for parametric for the AP exam. There are FRQs and multiple choice, so if you're struggling with this topic, this is a really good link to visit and do some practice problems for the AP exam. I hope this video was helpful.